This is a discussion of parallelogram properties, using parallelogram properties, and identifying whether something is a parallelogram given certain information. So we have parallelogram ABCD with certain properties. So there's a lot here. Let me explain what's what. We have two pairs of parallel sides, so parallel and parallel. These are parallel. Opposite sides are also congruent, so 2 slash 2 slash 1 slash 1 slash. The diagonals bisect each other. So this diagonal may be longer than this one, however, each diagonal is cut in half. So 3 slash 3 slash 4 slash 4 slash, opposite angles congruent, and the consecutive ones are supplementary. So two angles that are next to each other will be supplementary. And then another way of listing these is you have two pairs of congruent sides, two pairs of parallel sides, opposite angles congruent, consecutive angles supplementary, and the diagonals intersect each other at their respective midpoints. Okay, so let's see if we have enough information to say if we have a parallelogram or not. So angle SPT is congruent to angle SMT. That's only one pair of opposite angles congruent, so that is not enough information. So that would be no. It's always useful to draw in the figure to see. All right, angle SPX with angle TMX, and if those are congruent, we know these two sides are parallel because of alternate interior angles. These would be parallel sides, SP and MT, where PM is a transversal. And then TPX with SMX. And so if those are congruent, then we know that these sides are parallel, again, by alternate interior angles. And so now we have opposite sides parallel. So the answer for number 2 would be yes. That is a parallelogram. Number 3, SM congruent to PT and SP congruent to MT. So that's opposite sides congruent. So that is a parallelogram. SX and XT, and then SM and PT. Well, we have one diagonal bisected, one pair of opposite sides congruent, but that doesn't do it. That's not enough to give us a parallelogram for sure. And then let's see, PXMX and SXTX. Well, the diagonals have cut each other in half. They bisect each other, so that would be a parallelogram. And finally, the last one here is SP congruent to MT and SP parallel to MT. This actually works. If you have one pair of opposite sides, both congruent and parallel, that is a parallelogram. However, if it was a different set of sides, so that top and bottom were parallel, left and right were congruent, that doesn't work because that could be what is called an isosceles trapezoid, where these are parallel and these are congruent. So given as it is, where it's the same set of sides, parallel and congruent, then number 6 would be yes, that is a parallelogram. And you could show that using congruent triangles. I'm not going to go through that now. Okay, for number 7, this is now using some properties to set things equal to each other and solve some algebraic problems. So for number 7, we could say opposite sides are congruent. So x plus 26 is equal to 4x plus 20. Subtract 20, subtract x, divide by 3, so x is 2. So now that I know that, I can plug it in over here, and I get 21 for this side. And so now 7y is equal to 21. So if 7y is equal to 21, we know y is equal to 3. Let's see. For number 8, we can say that 2x plus 14 is equal to 5x minus 4 because the diagonals are bisect each other. Add 4 to both sides, subtract 2x, divide by 3. And now we know that x is 6. This piece in here would be 6. So we know that 6 is going to equal 2y because those pieces have to be equal to each other since the diagonals are bisected. So y is equal to 3 when you divide by 2. Now for this one, we could say the opposite angles are congruent, but then we'd have two different variables. So it's better to start off saying consecutive angles are supplementary. So 12y plus 8 plus 5y plus 2 is equal to 180. So I get 17y is equal to 170, subtracting the 2 and the 8. So y is equal to 10. And now that I know that, I can plug it in, say, to this top one, and I get 10 times 12 is 120, so 128. And 128 is going to equal 2x because opposite angles will be congruent in a parallelogram. So x is 64 if you divide both sides by 2. Okay. Basically more of the same in 10, 11, 12. Set these guys equal to each other to find a value for x, and then you plug it in here, and if they're the same thing, then you know you have a parallelogram. Same idea for this problem. Set these guys opposite, they're equal to each other, find out what x is, and then make sure that these are also congruent to each other. Skipping down to the last set, do we have enough information to say whether it's a parallelogram? Here the diagonals bisect each other, so this would be yes. Here you've only got one set of sides opposite congruent, so that would be no. Here you have parallel sides for one set of opposite sides parallel, but the other one is consecutive sides congruent, not opposite. It have to be down there, so that's no. For this one, opposite sides congruent. That's good enough. That's yes. Over here, if these guys are congruent, they're alternate interiors, so those are parallel. And if these guys are congruent, that means these are parallel. And so the answer is yes, you got a parallelogram. This is one pair of opposite angles congruent as opposed to two, so that's no. 19, as I mentioned, works if you have the same pair of opposite sides congruent and parallel. That's parallelogram. And finally, 20, you've only got one set of opposite sides congruent, so that's not enough information. That would be a no.